So let's look at 6 on page 407. So it's 9:22. Let's say about 15 minutes on this review. And this is 49a squared minus 16. And then 13, negative 4 r squared plus 1. I'm just copying a few. 49 y squared plus 1. (25) 8a cubed minus 1. So I'll work with you on 405, and then you work on 405. And then we'll continue with trinomials. Okay, the first one. All of them are asking us to factor completely. So the first one. First question. What type of polynomial is it? It's a binomial. Question number 2. Is it in descending order? Once you are getting used to all this strategy, this should happen in your brain in 10 seconds. And the factoring. But we need to take it easy. I know. So is it in descending order?
Yeah.
Yes. Greatest common factor.
Yeah.
There's no greatest common factor or common factor to both terms.
Oh,
49 and 16 have nothing. Correct. Good. Negative leading coefficient. No. Special product. So notice I went through all these. What type is this? Is it in descending order? Greatest common factor, negative leading coefficient. Now I have to identify it. 1, 2, or 3. You already told me, because that's the first question, right? It's a binomial. So now I'm asking myself, can I apply any of these products? Special products. Difference of squares. Once you say difference of squares, I know I have to come up with 2 binomials. If you say difference of cubes, I'll say, no, that's not going to be a product of two binomials. It's going to be a product of a binomial and a trinomial. But once you said difference of squares, I prepare 2 binomials. And the binomials are? Awesome. 13. Negative 4 r squared plus 1. First question, what is it?
Binomial.
I know I sound like a broken record, but it's the only way. Sorry. It's a binomial. Is it in descending order?
Yes.
Negative leading coefficient.
Yes.
Greatest common factor.
No.
Very good. Your book does not, in this chapter, does not factor out the negative leading coefficient. And in chapter 7, next chapter, which is an application of chapter 6, they say, oops, sorry, we forgot to tell you.
So factoring out the negative leading
It's
coefficient.
mandatory no matter what the book says.
No, that's fine. But all it is taking the negative sign and putting it outside.
Yes.
Okay.
However, whatever is left in parentheses has to match.
Right.
Negative times whatever first term you give me, it has to give us this.
Right. So then what?
And negative times whatever is the second term has to give us this.
Right. Okay.
I'm ready.
It's a clue on how to solve it. So is that an R you have written down here?
I know. Sorry.
That's okay. So would it be 4R? Yeah, squared.
Very good.
Yeah.
Remember I showed you last time? I can factor whatever I want from whatever you give me. Right? As long as in parentheses, I have the appropriate quantity. So as long as I show you that this times this is this, and this times this is this, I'm fine. Good. So now, special product, yes or no? Very good. Once you said difference of squares, I know I'm going to have to write two binomials. What are they? In any order you want. Is that clear? Okay, next one. What type is it? Descending order?
Yeah.
Greatest common factor?
No.
Negative leading coefficient?
No.
Special product?
Yeah, sum of squares.
Good. What is it? How do I factor that?
You don't.
Very good. Awesome. Next one. What is it? Descending order?
Yeah.
Negative leading coefficient?
No.
Greatest common factor?
No.
Special product? I always hope for a special product. Anything else is more difficult. Anything else is more difficult. The special product is always the easiest.
Difference of cubes.
Once you say difference of cubes, then I'm expecting a binomial times a trinomial. When I identify the binomial correctly, the trinomial will follow. Easy. So the sequence of signs first. It has to follow, the binomial always follows what I'm factoring. Always. Yes, it has to be negative. So the sequence of signs is either minus minus plus or plus plus minus. Good. What do I cube to get 8 cubed?
Wait. So if the first term starts with a minus, it has to end with a plus,
If I'm factoring the difference,
right?
the binomial has the same sign. So this one has to have the opposite. If I factor the sum, the binomial has to have the sum.
That's what I was getting confused with last night. Okay.
This one would be always the opposite.
Okay. All right.
So either minus minus plus
Mm-hmm.
or plus plus minus.
Okay, I understand. Thank you.
Or we can write it here on the handout if you want. So the sequence is plus plus minus or minus minus plus. So you know what that means. So write something in there that says, hey, this is for sum of cubes, difference of cubes, whatever, so you know what it means. So or you just show it here in these two or put an arrow, whatever works for you. Good. So please let's identify the binomial. Okay, so here's the question. Yes, very good. Good. So now, the pattern for the trinomial is easy because we know that special product from trinomials. So it's this squared, the product without the 2. Remember I said first term squared plus 2 times the first, no, this one does not have the 2. So the first term squared plus the product, just the product here, plus this squared. So what do we write?
Squared.
I want the answer. You have to already imagine 2a in parentheses and squared. You have to square 2, you have to square a. Very good. Plus. That's why we established the sign so we don't make the mistake. That's why we put minus minus plus from the beginning so I don't have to reconsider and make a change and make a mistake. Just 2a. The product. 2a times 1. Plus
1.
Yes, because it's 1 squared. Is that okay?
Can you solve that problem again? Because I was having issues with it last night.
So what a quantity cubed is this? 2 cubed is 8. A cubed is A cubed. What quantity cubed is 1 is 1. So this is the first term, and this is the second term. And now this says the first term squared plus the product of the two plus the second term squared. We'll have more examples. You'll feel better in a couple of minutes. Okay, ready? 29. 5k to the third plus 40. Please start working on this. I'm going to choose a few more. 46. 2x cubed plus 54. And 61. X to the sixth minus 81x squared. Do you need help on 29? I would like you to think for a moment. Do we have an answer for 29? Very good. So we start awesome. So first I have to identify what it is. It's a binomial. It's in descending order. Greatest common factor. If you skip the greatest common factor, you may not even be able to factor it. So that's why those steps are mandatory and in that particular order. So yes, thank you. Whitney said 5 parentheses. And then?
K cubed plus 8.
Very good. No negative leading coefficient. Good. So now I'm down to the special product. So is the special product applicable to k to the third plus 8? Very good. So do not drop the 5. 5 has to stay. And once you set the sum of cubes, I have to prepare. I'm waiting for a binomial times a trinomial. I want to handle the signs first. If this is plus, what is this?
Plus,
And what is in the middle?
minus.
Correct. Plus, plus, minus, or minus, minus, plus. So I put them first because I may be tempted to say, okay, I'm multiplying this, how come it's negative, how come it's positive? So put the signs first. Okay, now let's identify the binomial. Do you all agree with k plus 2? Okay. So now carefully give me the trinomial without multiplying 2 for the middle term. By 2 for the middle term. K squared.
4.
Without multiplying by 2. That's a special product from trinomials. So just multiplying this and this. 2k. Just k times 2 or 2 times k. And then plus 4. Now, what I recommend is multiply these for the first 5 problems you do. And you will see after you finish, multiply by 5, you will get 5k cubed plus 4. Okay, let's work on 46. 1 minute. Do not skip the steps. Identify descending order, greatest common factor, negative leading coefficient, special product. Do not skip steps, please. We need help on this? Just want to see.
I got the first part, but the second part is 2x3 plus 27.
Right.
But
So if this is positive, what would be this? No.
Plus.
So, yes. So if I factor the sum, the binomial has the same symbol. And this one is minus, correct. So you said this term cubed is this.
Yes, yes.
What term cubed will be this?
3.
Correct. Let's put it in. Very good. So now, this squared is here. How much is this product when you multiply 3 by x?
3x.
Let's write it. And then plus this squared.
9.
Correct. Now, in order to convince yourself that this is correct, distribute x to these 3. Distribute 3 to these 3. When you simplify and you're done, at the end, multiply by 2. So just write on the side, check. So you know what, are we done? Okay, so this is x squared, perfect, minus. This times this, plus this squared. So x to the third is this, but 9 to the third is not this. How are we doing? Good?
I have a question now. So for this other one, I'm trying to figure out this number at the end.
Yes,
Is
that's
it-
correct.
This is correct actually?
Yeah, so this is not, because you have to square it 3.
No, I'm saying, is this whole thing correct?
You have to put 9 here instead of 3.
Oh, okay, so I had them backwards.
Yes,
Actually.
yes.
Okay, I knew it was close.
Anyhow, yes. Okay, perfect. Good. So you factor out 2. Without factoring out 2, you can't find anything, right? You see how important the greatest common factor is to be pulled out. So then you had x to the third plus 27. And now this is a sum of cubes. Of course, I skipped steps because I already saw what you did. What is it? Binomial, descending order, yes. Greatest common factor, yes. Negative leading coefficient, no. Special product, yes. So I saw you wrote a binomial times a trinomial. What quantity cubed is this? X. Of course, a sequence of signs. If this is plus, the binomial has to have plus. These two have to have the same sign. So then you wrote 3 because 3 cubed is 27. This squared is here. This squared is here. This product is 3x. And the last one is plus. Better? Okay, so x to the 6th minus 81x squared. We want to completely factor this one. Yes? Whitney is way ahead of us. So, yes, it's a binomial, it's in descending order. Greatest common factor, yes indeed. We have to pull out x squared. And what is left in parentheses? If I write x cubed, I'm in trouble. Why? Why am I in trouble if I write x cubed? Because when I distribute, copy the base, what happens to the exponents?
You add them.
Right. And 2 plus 3 is not 6. So, yes. So it's x to the fourth minus, yes. I saw some, in some of your work on this test, you got confused on those powers and stuff, right? So let's review the powers quickly. When I multiply quantities, you can never multiply the bases. I also saw some of you multiply the bases. I cannot multiply. So if I have a to the second power times a to the third power, I cannot multiply the bases. I'm not allowed to do that. So even before we finish this, I want to review this with you. Because 2 to the third times 2 to the fourth, you cannot multiply these two and say it's 4 to something. Not allowed. You can only copy the base and add the exponents. When you take to a power, this is the most powerful one. You copy the base and multiply the exponents. And when you divide 2 to the fourth by 2 to the fifth, yes, 4 minus 5 is -1, and that's why we have to write 1/2. So these are the 3 power rules that we have to remember. When we multiply exponential notations having different exponents but the same base, copy the base, add the exponents. When we raise to a power, copy the base, multiply the exponents. When we divide, copy the base. That's why I always say copy the base, and subtract the exponents. Okay, coming back. So what do I do now with x to the fourth minus 81? I'm asking myself, is this a special product? So I have 2 options for a difference. Either the difference of squares or difference of cubes. And I look at x to the fourth. And what do I say? Is this a perfect square or a perfect cube?
Neither one.
Can I find something that I squared to get x to the fourth?
Yeah.
Which is x squared. Right. X squared squared. That's why I reviewed this. If this is x to the fourth, this is x squared squared. Correct? So then, it's a difference of squares, and when you say difference of squares, you will get ready 2 binomials. And they are yes? Correct. Which of these 3 factors can still be factored? X squared. It's x squared. Now there is nothing I can do to it. What about x squared plus 9? Can I factor x squared plus 9?
Yeah.
Because it's the sum of squares,
Oh.
right? Can I still factor x squared minus 9?
Yeah.
Because it's the difference of squares. So it's not done until it's fully factored. Completely factored. So I'm continuing here. X squared, once you say it's a difference of squares, what would you give? And this is completely factored. I know we only did like, I don't know, 7, 10 problems last time and 10 problems today. 20 problems not enough to be able to quickly factor a binomial. So we need probably at home another 40 problems. Every now and then, not all of them at once today, because you will forget. Okay, do you think we can move on to trinomials?
Yeah.
Do we need more examples from binomials?
I did love binomials yesterday,
Good.
but I didn't come across this.
Okay,
method.
let's do it now. What is it?
I'm sorry, hold on.
Anything you worked on. So can we say that we have a good idea about how to factor binomials. I know the skill is not there yet, but can we say we can move on or not yet?
So I did x parentheses x plus 10 plus 17 parentheses x plus 10. 17. And these are all the questions I solved yesterday.
Oh, okay. I see. Good. I have not shown an example like this yet. And I'll explain why I didn't. Because basically this is more part of polynomials. But since you brought it up, let's do it now. We are going to do a lot more when we get to polynomials. Okay. So here we're given what it's called a binomial. But it's so-called a binomial. Why? This is a product. So this is one term. And it's one product. One product. Plus another product. So I could say this is a binomial. It's not. It's more than a binomial. Because if I distribute, then combine like terms with, it's something else. So it's more than that. It could collapse into a binomial, but right now I can say it's so-called a binomial because there are one sum of two products. So I can say kind of binomial. Now I look at it carefully and say, is there a quantity that I can say it's the common factor to both? So this is the first term. I'm going to call it first term. And I'm going to call this second term. Is there a particular quantity that is common that I see it exists in both terms? Right. So I will pull out x plus 10. So it's out. Do not erase it like this. I'm just making a point. It's out. I pulled it out. What is left from the first term? Because remember, I have two terms. I have to have two terms in here. If I want to check, I will redistribute this factor to x, and I get this. I will redistribute this factor to 17, and I will get this. But this is what we deal with shortly after we review trinomials. Is there another problem that even if we are going to look at this in trinomials, if there is another problem, I like to do it.
The trinomials, I think the difficult part is finding the factors of the sum.
I agree. So put a mark on the problems that you want me to work out with in class, because I want to do the review first and then I'll come back to your problems. Okay. So I'm going to pick some trinomials, review this, and then we'll look at Ruby's problems. Okay. Okay. I'm picking now from page 411. They're all mixed in, all sorts. I don't see what I'm looking for at all. Yes. Okay. X squared plus 2x plus 1. That's the type of problem I wanted to start with. Okay. First question. What is it? Trinomial. Is it in descending order? Greatest common factor. Negative leading coefficient. No. When we ask about greatest common factor, I mean all three. Not just the first two or the first and the last and any other combination. Good. Special product. I always hope for a special product. Special products, although you may say they're not easy, they are the easiest of everything in factoring. Always hope for a special product. Is this a special product? And if you remember how we checked, like we did last time, How we check whether it's a special product? Where do I look? And the answer is at the first term and the last term. Okay. Is this a perfect square? Yes, because it's blah blah x squared. Is this a perfect square? 1 is a friendly number. It's a perfect square, it's a perfect cube, it's a perfect anything you want. 1 squared is 1. 1 cubed is 1. 1 to the 4th is 1. 1 to the 5th is 1. 1 is a friendly number. So the first term and the last term are perfect squares. So I'm hoping for this. For this is meaning what? But now if I am still fighting and foiling the formula, I may have difficulties here. What do I expect to have in parentheses?
X plus 1.
Correct. X plus 1. However, there is one portion that I haven't checked yet. What is the portion that I have not checked yet? The middle term. So what will be the middle term of this? From the formula that we start with every day. What will be the middle term here? 1, exactly. So this formula has the 2 in it. So 2x is the middle term here. If this middle term here is not 2x, this does not equal that. And I'll erase it. It's false. Do I have 2x here? So this is the correct factored form.
Wait, how did you know 2x again?
See? Because he's still foiling. No, I'm kidding. I don't know. From here I know the 2x. 2 times the first times the second.
Honestly, I'm really not feeling well. I think
I
I
see.
should go.
Okay.
Yeah, I'll pick up my shit.
Okay. I'm sorry I'm not feeling well. Rest.
Yeah.
So
glad-
you knew that as a result of memorizing that formula?
Yes.
Okay, that's what I wanted.
A plus b squared. First term squared plus 2 times the first times the second plus the second term squared. If you resist this, you will always have that question.
Not resisting, I just was curious where you were getting it from.
But what do you mean about the second term? You don't mean like the 2 x, you mean like the first and the last?
I'm only looking at the first and the last. If they are perfect squares, I hope for that something squared.
So,
But I still have to check the middle term.
I'm saying like so that.
Because remember, I gave you an example in which this was not a match. So that I cannot conclude is a plus b squared. If I only have here AB, I cannot conclude that this is a plus b over b squared. So that's why I look at the first and the last. If they are perfect squares and positive, then I conclude something, but then I'm not certain till I check the middle term. I know we need to practice this. Okay. Good. Let me, I'm not finding what I want. I'm going to go to a different section. Yeah. Okay. X squared minus 16x plus 64. What is it? Is it in descending order? Greatest common factor.
No.
All three have to have a common factor. So the answer is no. Negative leading coefficient. No. Special product. Yeah. So what do I hope for? I'm sorry, I should have not covered the sign. What is my hope? Careful. It's not ever the opposite for trinomials. If this is negative, then the binomial has to have negative. You are expecting, or you're hoping for, one more time? Squared. Don't forget to put the square. Okay. So one more time, what is the middle term here in this expansion?
16.
Yes, -2, right? It has to be negative. 2 times the first times the second. If this is not 16x, with minus in front of course, then the factor form is incorrect. So I have to erase this. Do I have 16x? So this is the correct form. Ready for the next one? Ready? 2n squared minus 28n plus 98. Change it into x because it's my n is different, so sorry. 2x squared minus 28x plus 98. What is it?
Trinomial,
Descending order?
yes,
Negative leading coefficient?
no,
Greatest common factor?
yeah, two.
Very good, very good. Do not skip that ever. Good. What is left in parentheses? Please dictate. Yes?
Nine?
I'm down to the step in which I ask myself special product, right? That's step number 5. Trinomial, descending order, greatest common factor, negative leading coefficient. Now I'm hoping for a special product. If it doesn't work, then I have to go to the other steps. Okay, so is the first term a perfect square?
Yes.
Is the last term a perfect square?
Yeah.
What is the sign in between?
Minus.
Good, what do you expect?
Minus.
So the 2, yes.
Negative two.
So 2 has to be outside. What do you expect? X minus?
Minus 7.
Good. X minus 7. One more step. What do I have to check now?
If the middle
Middle term. What will be the middle term of this expansion?
14.
A negative 14. X. Negative 14x. So one more time, Chris. 2 times the first times the second. 2 times x times 7. How much is that?